The principle of diversification states that spreading our investment across multiple assets will eliminate some of our risk. We can't get rid of risk completely, but we can get to a minimum level of risk that we cannot diversify against, which is that systematic portion. But diversification substantially reduces risk without an equivalent reduction in our expected returns on our investment. It reduces the variability of returns. So in chapter 10, when we looked at those graphs that showed how volatile different types of returns are, by investing in multiple types of returns, we can help to level out some of that risk. It is caused by, or the diversification is caused by, the offset of worse than expected returns from one asset by better than expected returns from another. So those assets balance each other out. This is an example of the on the New York Stock Exchange, what the average standard deviation of annual portfolio returns is, and the ratio of portfolio standard deviation to standard deviation of single stock are. So if a person were to randomly select one stock on the New York Stock Exchange, if you randomly selected just one and put all of your money into it, your standard deviation of return would be about 49% per year. However, if you randomly selected two stocks and invested 50% of your money in one and 50% in the other, your standard deviation drops to 37% and so on. At 500, your standard deviation is equal to almost the standard deviation that we saw of large stocks from chapter 10. So the average standard deviation of portfolio returns. Then we can see in the next slide. So as more stocks are added, each new stock has a smaller risk reducing impact on the portfolio. So you can see that our standard or variance falls slowly after about 40 stocks are included. So we see here that right here at the change between 30 and 40 stocks, we start seeing a very small change in that standard deviation. And from 200 stocks to 300 stocks, there's no change in that standard deviation. So forming well-diversified portfolios can eliminate over half the risk of owning just a single stock. It doesn't eliminate all risk because of the systematic risk, which is outside of companies' control. We can see here that that diversifiable risk drops from 49.2 for our average annual standard deviation down to 19.2%. So that is the range of our diversifiable risk, and what is left over is the non-diversifiable risk. The total risk that we have in a portfolio is the systematic risk plus the unsystematic risk. So our standard deviation of returns is a measure of our total risk. For well-diversified portfolios, we can almost take unsystematic risk to zero. So for total risk for a well-diversified portfolio, it is essentially equivalent to only the systematic risk of the market. The systematic risk principle from chapter 10 is that there is a reward for bearing risk. So if you remember, that was the very first principle that was stated in chapter 10. There is reward for bearing risk. However, the systemic risk principle takes that to another step by saying there is no reward for bearing risk unnecessarily. So by not diversifying, your taking risk unnecessarily. So the expected return or the market required return on an asset depends only on that asset's systematic or market risk. So taking on the extra risk by not diversifying, there is no reward from that. The market risk for individual securities, so the contribution of a security to the overall riskiness of an entire portfolio, is measured by a stock's beta coefficient. This measures the stock's volatility relative to the market volatility. So it's relevant for the stocks that we have in our portfolios. If the beta is 1, the stock has an average risk as compared to other stocks on the market. If our beta is greater than 1, our stock is riskier than average. And if the beta is less than 1, our stock is less risky than average. Most stocks have betas that range from 0.5 to 1.5. The beta of the entire market as a whole, so the average of the entire market, is 1.1. The beta of a treasury bill, which we know has no risk, is 0. So treasury bills don't have any risk because there's no risk of default. So the beta of a treasury bill or a government security is 0. This is a list of beta coefficients for a variety of companies in 2018. When we look at stock quotes, so if you remember when we were looking at chapter 7 and we were looking at the stock quote for Harley Davidson at the end of chapter 7 in the PowerPoint, one of the items that was listed in that stock quote was the beta coefficient of the Harley Davidson stock. So we have the various beta coefficients of the stock. So we can see here whether they're considered risky or not. So if we go back and we look at if it's over 1, it's riskier than average, under 1, less risky than average. So we see that Macy's stock is the least risky in this list, and Amazon stock is the most risky or the most volatile in the selected list of stocks from this list. The beta for an entire portfolio is the weighted average of the betas of the individual assets in the portfolio. The beta and our risk premium. So the risk premium equals our expected return minus the risk-free rate. So remember, the R with the little f is the risk-free rate. The higher the beta, the greater the risk premium could be. So there is a relationship between the risk premium and beta. We can estimate the expected return, and we can see this here. So we have the asset expected return, which is our ER, versus our asset beta. So the slope of the security market line is equal to the market risk premium, or the reward for bearing an average amount of systematic risk. So the equation describing that's called the security mark line, which is the security market line. So we can see the equation for the security market line is the expected rate of return equals the risk-free rate plus the expected rate of the market minus the risk-free rate times our beta coefficient. This, in addition to being the SML equation, is also the capital asset pricing model equation. That is also pronounced as CAPM, or CAPM. The reward to risk ratio is the slope of our line on a graph. So that is the expected rate of an asset minus the risk-free rate divided by the beta coefficient. In equilibrium, this ratio should be exactly the same for all assets. When the expected rate is plotted against the beta for all assets, the result should be a straight line. in an efficient market. In equilibrium, all assets and portfolios must have the same reward to risk ratio. And the reason for this is because this market equilibrium is because if one stock had a much higher return over another stock, then that stock is going to be purchased over the other stock, meaning the price of one is going to drop and the price of the other is going to increase. So we look at the ratio as it equals the reward to risk ratio for the entire market as a whole. So what is the ratio of each asset versus the reward to risk ratio for our entire market? The security market line is the representation of the market equilibrium. Since the beta of the market is always 1, the reward to risk ratio, or the slope of the market. Remember, if the market is completely equal, this will be a straight line. Our security market line is part of our capital asset pricing model, where RF is the risk-free rate. That's the rate of a treasury bill or a treasury bond. The RM is our market return, which is equivalent to the return on the S&P 500. We have the market risk premium, which is the expected market return minus the risk-free rate. That is our market risk premium. And then the expected return of an individual asset. The capital asset pricing model shows us the relationship between risk and return by using the premium risk return and the beta. If an asset's systemic risk beta is known, then we can use this Kaplan pricing model to determine the expected return of an asset. This is an example where we're going to look at stock A versus stock B. So we have the expected rate for each individual stock. We have the beta coefficient for each one of these stocks. We also have the market return and the risk-free rate. So it tells us that stock A is undervalued and stock B is overvalued. So when we look at that required rate of return versus our expected rate of our asset, which is, let's just look at stock A here. Expected rate of stock A is 14%. Our risk-free rate, 7.5%. The market return, 12%, minus the risk-free rate of 7.5%, times our beta of 1.3. Gives us a required rate of return of 13.4%. Factors affecting our required return. So the risk-free rate measures the pure time value of money. And the risk premium within the market measures the reward for bearing that systematic risk. So remember, that's one of the main principles, is that there is a reward for bearing risk. And then the beta of the individual stock measures the amount of the systematic risk for that individual asset.